Alright guys, welcome to RC Mojo. This week we're going to get a ClodBuster running under its own steam. We've got a FlySky 3-channel receiver that will bind with a GT3C, and we've got a HobbyWing Quicrun 880 dual motor ESC. Yes, for now we're going to go with brushed motors for that extra little bit of nostalgia. I tried to source a new in-box Novak Super Rooster, but they're rather expensive now, and in the UK even a well-used one isn't all that common. To be honest, the 880 is going to be just as good or perhaps even better. It just would have been fun to have that huge old orange ESC on the chassis. We'll start with the ESC as there's a fair bit of prep to do before it's usable. But first, a warning. Most, if not all, HobbyWing ESCs have fake copies that are of dubious quality. This one has a Schumacher sticker on the box, which is under the cellophane. A good indication it's come from the proper UK distributor and isn't a great import. Usually, if you buy from one of the usual big stores, you'll be okay. In the box we have the ESC, a small fan, which is fun. Not sure we're actually going to need it though. A length of red wire, not sure what it's for. It might say in the manual, but whoever reads that. I initially thought that maybe I had a Duff ESC and it was the positive battery lead. There's a couple of bits of servo tape, one to attach the ESC and one for the switch. And lastly, of course, you get the manual, a couple of zip ties and a sticker sheet. All the usual stuff for a HobbyWing then. It's kind of a shame it doesn't come with the programming card, but at the same time I'm kind of glad it didn't. I've collected 7 or 8 of the things for the WP1080. We'll have to get one for this ESC at some point just to see what we can configure. Without the card we can still set up most things if we really needed to, but it uses a combination of throttle and motor beeps for feedback, which is always a bit frustrating. If you look at the ESC, we see yet another Schumacher sticker. Thankfully they've stuck it on the side. On the 1080s they tend to stick them on the bottom so they get covered up with the servo tape. What makes the 880 a bit special is it's designed to run 2 brushed motors. There's no magic here though. You can think of it as having a motor Y lead built in. The 2 yellow and the 2 blue leads are connected together on the PCB. The advantage is, of course, it makes for a really tidy install. And the ESC is specifically rated for 2 12-turn motors on a 2S LiPo, so you don't have to guess. Now, you may have noticed the ESC doesn't come with a battery connector, so we've got a bit of soldering to do. We're going to use an XT60, so we're going to need a male and a female connector and a shroud. For a bit of insulation, we're going to use a couple of bits of heat shrink too. First then, we slide the shroud over the battery leads, followed by the heat shrink. Now I can't tell you the amount of times I've forgotten one or the other, especially when soldering a stack of batteries, so make sure you don't forget. Now the end of the battery leads have already been stripped and tinned, but I'm not sure what solder they've used. So to get the best joint, we'll just snip the ends off, strip the insulation and re-tin. When soldering battery or motor wires, you're going to need a fairly beefy iron or soldering gun. This old Weller is 140 watts, which makes life really quite easy. Trying to solder with a small iron can be really quite frustrating. To tin the ends, I usually dip them in some flux to get the solder flowing nicely, but rosin core solder should have enough flux in it already, but more never hurts. When soldering XT60s, and most other connectors for that matter, it's not a bad idea to plug a pair together. If you get them a bit hot, it gives you a bit more time before the plastic gets a bit melty and you start to distort things. Now we clamp the connector in a pair of pliers so they don't run away, and we're ready to solder. XT60s have a standard polarity, and helpfully there's a small plus and minus on them, so unless you're particularly dopey, you can't really get them wrong. We'll add a smear of flux to the connector and tin them. We want a good bit of solder in there, just enough that it won't overflow when we pop the wire in. It's not that easy to judge, but you do kind of get a feel for it after you've done a few. To solder the wire, we want to preheat the solder in the connector by re-melting it. Take the iron away and put the tinned wire in and heat it up. Try and get the iron tip in so it's melting the wire and the solder in the connector. Most of the heat will transfer through the wire, but any help you can give it will speed things up. Once the wire has sunk into the solder and it's all nice and molten, take the iron away and support the wire until the solder has cooled. If you don't have heat-proof fingers, you might want some tweezers or something to hold the wire. I do enough soldering that my fingers have long since given up trying to warn me when they're getting a bit warm. The other lead is exactly the same. Preheat the connector, pop the wire in and heat up the whole joint. It's one of those things that's really quite simple to do, but there is a bit of a knack to it. You can only really get the hang of it though with practice and getting it wrong. Next we can slide the heat shrink up and use a heat gun to shrink it. This is completely optional. The shroud should be more than up to the task all by itself. I tend to go for the belt and braces approach though, so if the shroud should ever get cracked, or a random U-shaped piece of metal somehow finds its way in, it can't cause problems, extremely unlikely as it is. The shroud can now push right down onto the connector. The heat shrink can make it a bit of a fiddle, but work at it and it will clip into its slot. What we're left with is a very solid, easy to grip, low resistance connector. Excellent. Next up we have the motor connectors. We've currently got the old-fashioned automotive style bullets, pretty terrible 50 years ago and still pretty terrible now. I mean, they'll work, but they're bulky and not the lowest resistance. Back in the day of silly brushed motors, I was running enough power to weld the bullet connectors together with the heat. To replace them, I'm going to use some 3.5mm banana connectors. They're much smaller and have a much lower resistance. Most of this is exactly the same as the XT60s. We clip the old connectors off, strip the wires and tin the ends to get them ready, feed a load of solder into the solder end of a female connector, offer up the wire and reheat the joint until it's nicely flowed together. Now I went a bit overboard here with the solder and it flowed out to the outside, so I swapped it for another one and didn't use quite so much solder. All nice and tidy. Rinse and repeat with the other three and they're ready for some heat shrink. It slides over the end where we position it, so it's just a bit less than 0.5mm over the end and we heat it up. Rinse and repeat and that's the ESC ready to go. A bit more effort than you really need to apply, but we should end up with a very tidy install. Right, the chassis. We've got a rather nice carbon fibre plate to stick the bits to. It almost seems a shame to cover it up. First, we need to work out where the bits want to sit. We'll plug the steering servo into the receiver and get a feel for where it should be. The servo lead's going to run along the top suspension link, so the receiver wants to sit somewhere just in front of centre, leaving enough excess wire to make it tidy. The ESC then wants to sit towards the back, and there's no worries about its servo lead as it's really quite long. The battery connector is well placed and the motor leads can easily be routed along the sides. Now before we start with the servo tape, we're going to spray some 99% IPA around and clean up any oil and grease so it actually sticks. We need to give the plate a quick wipe along with the bottom of the ESC and receiver. For the ESC we're going to use the tape that came with it. It's proper 3M stuff, so it's going to do the job perfectly. We'll stick it down nice and square, about 5mm from the back edge. For the receiver, we'll cut some servo tape off a roll and stick it down around 5mm in front of the ESC. The gap here being fairly important for keeping the wires tidy a bit later. Starting at the front, we need to make sure the steering servo lead can't get caught up in the suspension. We'll use the nice skinny zip ties that came with the ESC. We're going to want a bit of slack up the front, so as the suspension moves it's not stressing where the lead enters the servo. We don't want to zip up the zip ties too tightly, we just want to hold the wires but not crush the insulation causing damage. We'll plug the servo into channel 1 and tuck the lead in between the receiver and ESC. The ESC servo lead is a bit more of an issue as there's quite a bit of excess. There's a few methods, but what I tend to do is fold up the wire. If we roughly position the wire so it runs up in the gap, we can fold it back on itself a few times and use another zip tie to hold it together. Again, we don't want to zip it up too tight, just enough to keep it neat. The lead can now go between the receiver and the ESC along with the servo lead. Get plugged into channel 2 and that's the servo leads installed. Next up we've got the motor leads. We'll need a blue and yellow pair running to each end. I'm going to use some black wire on the motors with banana plugs. Usually I'd use blue and yellow like the ESC, but on the Clod they're going to be quite visible, so black will hide them quite nicely. What we'll do is solder a plug on the end of the wire. Now I'm not going to show that here as it's exactly the same as the sockets. plug it into the ESC and run the wire to the motor. We need to keep in mind the motor is going to be moving up and down with the suspension, so we're going to need quite a bit of extra so nothing gets stressed. Do the same with the other 3 leads and we're ready for more soldering. Just like the other wires, we're going to need to strip some insulation and tin them. We'll use a bit of extra flux too, adding a bit to the motor terminals. Now, because access is a bit tight, I'm going to use some tweezers to hold the wire so the end is sat on the lower motor terminal. Once it's in the right spot, we can heat up the joint, keeping hold of it until it's cool. And that's 1 done. We've still got 3 more to do, but it is worth noting that there's not a vast amount of clearance with the stock motors, so you have to run the wires so they won't rub on the chassis. Once we fit some hotter motors with open end bells, that's not going to be a problem. Next then, before we strap the motor wires down, we need to power it up and set up the transmitter direction and swap around the motor connection so both axles run forwards. To be safe, just in case the truck takes off by itself when we turn it on, we'll pop the axles and chassis up on some old HobbyWing boxes. As it turns out, they're just the right height. Right, the radio is already bound. It's the same receiver we installed on the old chassis, so all we should need to do is connect up a 2S LiPo and turn it on. Well, sounds like it's working. We have the steering, and in theory that should still be set up okay, as it was working fine on the old chassis. For the throttle though, nothing happens until the second pump of the trigger. That means we're applying the brakes, then going into reverse. So the throttle channel is backwards. It's an easy fix, of course. We turn the truck off, go into the reverse menu on the transmitter, and we reverse channel 2. Now if we power the truck up again, we should see the motor spin up instantly when we pull the trigger. And there we go, it does. But now you might be able to see the rear axle isn't going the same direction as the front. Not very useful. We need to turn the truck off again, and this time swap the connectors on the rear motor. And now, if we power it up again, we should have a nicely set up setup. Yep, that looks good to me. It'll be interesting to see what options are on the programming card when it turns up, but for now, it looks like it's going to do just fine. Off camera then, I've strapped the motor wires down to the cross members on the chassis, just using 2 zip ties in a cross to guide the wires. There's plenty of excess wire too, so as the axles move up and down, nothing's going to get pulled or stressed. Next then, we've got to do something with that antenna. The chassis is made of carbon fibre, which is rather good at blocking radio signals. You'd probably get away with just stuffing the antenna somewhere, but for the best range you need to get it up above the carbon. I've very quickly made up a 3D printed mount that we can servo tape to the electronics plate. It's just a rather square, quickly done print, but it'll work. We feed the antenna up through the side hole and out of the top. Stick it down to the plate and pop in some antenna tube. Nice and simple, and should give us more range than we're ever going to need. Power switch next. Now we could just stick it down with the tape that the ESC came with, but it's got 2 perfectly good screw holes. So I've been at the 3D printer again and made up a little mount. It sits across one of the U-shaped holes in the chassis and uses existing holes to mount, which you can't see. There we go. It's got 2 holes for a couple of M3x6s to mount to the chassis. Then we use a couple of M2 screws to mount the switch. A bit overkill, but it will save the annoyance of the switch falling off when the servo tape gives up. Right, one more thing before we can do a test run, we need to mount the battery. The chassis comes with a nice set of Velcro straps, 2 long ones and a short one. We're going to use a full length battery, so we'll need to feed one of the long straps under the battery plate. There's some cutouts in the aluminium cross members that the straps just about fit through. They're a bit tight, but that's not a bad thing. Once the strap's in, it's not going to fall out by itself. To get the battery in, we need to compress the rear suspension so there's enough clearance between the battery plate and the motor. It would be a bit easier with a battery that has sockets at the end rather than fixed wires, but this will work. Now we just feed the Velcro back through the loop and pull it tight. Now we could also use a short strap across the battery plate for some extra security, but I think the single strap is going to be good enough. The battery feels nice and snug, so I don't think it's going to go anywhere. Okay, final test. Transmitter on first. Plug the battery in. Pop the body on. Turn on the ESC. and well, it's alive. It's surprisingly good at low speed. The ESC is doing quite well considering the motors and the gearing. Reverse seems a bit fiddly to get into though. You have to go well into the brakes before it'll trigger on the second pump. I wonder if there's a setting for that on the programming card. Either way, it's all working, so let's pop out to the woods for a quick test run. I'm going to upload the test run on its own at the full 50 frames a second. It's only a couple of minutes, but the higher frame rate does look a lot smoother. For this video then, that's about it. So, as always, thanks for watching, like if you like, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys!